Children, let's take one more interesting sum. Read the question and then I'll make you understand what we need to do so. Marbles, which are spherical in shape, of diameter 1.4 centimeter, are dropped into a beaker. Beaker is cylindrical in shape, containing some water. So within the beaker, there lies some water. To what height the water is being filled, it's not given to us. Even we should not be interested also. And are fully submerged. The diameter of the beaker is 7 centimeter. Find how many marbles have been dropped in it if the water rises by 5.6 centimeter. So we all are aware that if we have a container in which there is some kind of liquid or water, and if we immerse some object, there will be a rise in water level. Right, children? So it belongs to Archimedes' principle. Volume of the object immersed inside the liquid is equals to the volume of liquid raised or rised. Right? Let's draw the diagram to make you understand. And thereafter, I would like to give you one general formula from my side. First of all, let us understand the diagram. Do we have a beaker? Indeed. We have a cylindrical beaker. Is it filled with water? Yes. Let me say that it was filled initially to this height. After the marbles were dropped in, so now we are dropping the marbles. So some marbles were dropped. How many? We are not aware. The moment the marbles are being dropped, n number of marbles being dropped, the rise in the water level is this much. But naturally, there is going to be rise in water level. They say it rises by, so this is the height which is given to us, 5.6 centimeter. Right? I'm supposed to find out how many number of marbles have been dropped. Now, before I actually move, I hope my children have understood the diagram and what is the actual sum all about. Now, before I proceed further, I would like to give you one simple example so that we try and create a general formula. In my language, this is problem based on number, where we need to find out how many marbles have been dropped. Means we need to find out the number of marbles. So whenever we have to find out number of something, we have a general formula. But before that, a simple illustration. Say, children, I'm having a bottle of any soft drink. Say it's a 2 liter or 3 liter bottle of any soft drink is there with me. And I give to some of my students 100 ml empty glass. I'm having a 3 liter bottle of soft drink, and I'm giving rather to all my students 100 ml empty glass. To how many students can I serve? The answer is very quick from your side, and there are many who answered also 30. There are many who answered that, sir, you can serve 30 students. Now, what made you do so and give me a very quick answer, 30? You all people must have converted that 3 liter into milliliter. So 3 liter, when we convert into milliliter, is 3000 upon glasses being given to each of the students, which is 100 ml. So 3000 upon 100, 2 zeros will get cancelled off and we are left with 30. Right? This is what the normal calculations everybody must have gone with. Here comes the formula. What did you all do so? 3000. In my language, I shall say that is the volume of bigger object. Thereafter, you said divide by 100. In my language, that is the volume of each smaller object. Will give me the number. Will give me the number. Henceforth, whenever there is a question which has number in it, find number of dash, find number of dash, will always say volume of bigger upon volume of each smaller. What are we going to remember? Whenever there is a question which is based on number, for that matter, to find out anything, find number of dash dash dash, will simply apply volume of bigger upon volume of each smaller. Right, children? Let's start. Who is bigger over here? According to you, cylinder. And who is smaller over here? Marble. Right? Let's start what we have to say so. First, I shall say for cylindrical beaker. For cylindrical beaker. They say the diameter is 7 centimeter. So the diameter D is 7 centimeter. Therefore, radius R is 7 by 2, 3.5 centimeter. As we are aware, radius is half the diameter. Next, to what height the volume of water level rises? Can I say the water level rises from this portion to this portion? So what is the height actually? The height is 5.6 centimeter. So can I say height of water level risen is 7 centimeter. Height h, if you want you can write down entire word, the complete word, height h. So what is the volume of water level risen? Volume of water level risen is this much. Am I right, children? And what is that? Pi r square h. Pi r square 3.5 square h 5.6 cubic centimeter. Sir, you have written the units. Units are very, very important. Let me tell you first thing. But you did not solve it and you have written down the units. Children, one more tip, one more technique. Whenever we have sums of this nature, what nature? To find out number, we shall never ever go and do any kind of calculation. Why? Because when I say volume of big upon volume of each small, maximum terms will get cancelled off. So why unnecessary waste time in finding out the calculation? No, we will never. We will never. Who is the smaller one over here? So now comes for marbles. For marbles, let R1 be the radius. Marbles of diameter. So we need to write down the diameter. So the diameter is given to us. Diameter D1 is 1.4 centimeter. Therefore, radius R1 is 1.4 by 2, 0.7 centimeter. Right, children? What is volume of each marble? Volume of each marble. What's the formula for sphere? We have learnt pi r1 cube. So it's 4 by 3 pi. R1 is 0.7 cube. Just now we learned one formula. What? Number of marbles is equals to volume of big, which according to us is this. Volume of water level risen, or you can say risen, upon volume of each marble. What is it? Pi. Instead of saying 3.5 square, can I say 3.5 into 3.5 into 5.6 upon 4 by 3. So 4 by 3 into pi 0.7 into 0.7 into 0.7. Now children, one simple thing is what I am going to tell you in order to make your calculation easy. Remember this. Though I have decimal, I'll check how many decimals do I have. 1, 2, 3. I'll check 1, 2, 3. Can I say I can ignore all the 3 decimals? Why? Here also and here also. Actually, you all say multiply by 1000 on both the sides. But instead of saying that, that's the same thing I'm doing. When I say I'm ignoring means I'm multiplying by 1000 only. But I'm not showing that. I'm not showing multiply by 1000 on both the sides. That is numerator and denominator. We have ignored it. And before that, pi gets cancels off, pi being constant. This 3 shall go up. 7 ones are 7 fives are. 7 ones are 7 fives are 7 ones are 7 eights are. This 3 shall go up. I am left with 3 into 5 into, I'm sorry, there is 4 left, still 4 left. I'm sorry, there is still 4 left. 4 ones are 4 twos are. 4 ones are 4 twos are. Now are we done? Completely. So what our answer is, 5 into 5 into this 3 when goes up into 3. Mind you, this 3 will go up. So 5 into 5 into 3 into 2. 5 fives are 25 threes are 75 twos are 150. So how many marbles have been dropped? 150 marbles have been dropped. Final answer, how many marbles have been dropped? Therefore, number of marbles dropped are 150. Number of marbles dropped are 150. Right, children? What did we learn from this sum? Whenever we have a question which is based on number, answer is always volume of big upon volume of each small. Right?